Having an indicator light that tells me when the drive thinks it's ready is handy, but the real value is it reminds me that even after the power is removed from the drive, the big electrolytic capacitors in the drive take time to bleed off. But keep in mind, that's only a reminder. There's still significant charge in the capacitors even though the light's off. For example, you can see the display is still active and it will be for several minutes. Now, the official word in section 1.3 of the user manual is to wait 10 minutes after powering down the drive before servicing it. I think that's pretty conservative, so I usually just wait for the display to go totally out. You do what you think is safe. Now, the status light is actually more than that because it also tells me if the drive has a problem or a fault. I think of it as my check engine light, except it's lit when everything's okay. So it's really my drive OK light. For example, I'm currently using input 3 for their local remote switch. That was done by setting parameter 265 to a 9. If I try to assign input 4 to also be the local remote switch by setting parameter 266 also to be a 9, as soon as I hit enter, the drive issues a fault and the drive ready indicator turns off because the drive doesn't know what to do with two inputs assigned to the same purpose. Undo the fault condition, and the drive tells me it's now ready. Cool. I really like having that drive status light. And it's super easy to do. We just assign an output to be the drive ready signal. Normally, I would use the built-in relay contact output for this, but I already used that guy to control the automatic dust collection, which you can learn about in this video. So to add more outputs, we just plug in an optional I/O module. This one has 3 more outputs and 4 more digital inputs. There's other modules that feature analog I/O, high-speed I/O, etc. Now, installing the module is a little bit awkward, so let's walk through it. To remove the front cover, you have to pull down, and it takes a little effort. It's in there pretty good. These are the hooks on the cover that you're trying to disengage. We have to remove any existing wiring because it'll get in the way of plugging the module in. The module has to plug straight in because these pins have to line up with this connector. Now you just plug it in. So if you know you're going to add an I/O module, do it before you do your wiring. Okay, I'll put the previous wiring back, and we're now ready to wire the output module. These are outputs 2, 3, and 4. And let's use output 2. I'll go ahead and add some wires for that here, and then replace the front cover by placing it a 1/4 inch low and then sliding it up. And you'll probably have to give it a bit of a bump to snap it into place. Now, output 2 is parameter 276. The output can do lots of things, but we want to output the drive ready signal to control our indicator, so we'll set it to a 12. That's it. We're done configuring the drive. And you don't have to power cycle the drive or anything. Output assignments take effect immediately. I wired output 2 like this, so when the drive ready signal goes active, it closes the relay and applies power to the indicator bulb in the drive on-off switch. I'm using 24 volts because that's what I had available, and I selected a switch that had an indicator bulb that was compatible with that. Now, the drive's relays can handle up to 250 volts AC at 5 amps, so you can use pretty much any kind of indicator you want. So, given that setup, I can now see when the drive thinks it's ready, how long it takes the drive's capacitors to dissipate some of their charge, and if the drive is faulting out. Exactly what we're looking for. Links to all the parts I used are in the description below the video.